Welcome to another video. This is a Mathematics Olympiad problem from many years ago, and I just found it and I started working on it all day, and ultimately I think I found the answer. Leave a comment in the comment section and let me know what you think, if I got all these solutions, but I think I did, because the first time I didn't get all the solutions, and I figured I started getting more answers because of the option that I chose. Secondly, please leave a comment in the comment section. I just want feedback on whether this video is shaky or not, because a video in the past was very shaky and I got another comment today again about shaky videos. So it's the same thing I've been doing, and I think it's the construction in the neighborhood that is causing the unseen vibrations in the videos. Let's get into the video. So the first thing you want to look at is what's going on the left-hand side and what's going on the right-hand side. The left-hand side is a square. You see? That means the right-hand side must be greater than or equal to 0. The right-hand side cannot be negative. The worst that you can get or the smallest, I don't like saying the worst, okay? The smallest that the right-hand side can be is 0. But it can't even be 0 because you got, well, it can't be 0 if this is a negative integer, but there's no way this can be a negative integer. If this side is 0, then y has to be some negative fraction. But y cannot be a fraction because it's supposed to be an integer. So the smallest value this can be is 0, right? So y must be 0 or a number greater than 0. That's the first secret to this question. Okay, so let's write that. Y is greater than or equal to 0, just by that observation. Now let's do something else. If y is 0, let's even try that. Let's say y equals 0. If y equals 0, this becomes 0, and this is 0. So that means x squared, because this is now 0, equals 1. Ooh, so that implies that x to the 4th is equal to 1. And if x is an integer, we're not looking for complex solutions. If x is an integer, then x must be 1 or minus 1. So immediately you can already see that we found a set of solutions just by that simple basic reasoning, okay? Which implies that when x equals minus 1, this is a solution, and 1, 0 are solutions. Ha! If it was this easy, then it would not be in the Olympiad. Okay, so we found 2 solutions, but they said find all. So we have to keep thinking, and let's just figure out what can happen. So now I'm thinking, wait, I see difference of 2 squares. That might lead us somewhere. If I move this one over here, okay? If I say x squared minus y squared minus 1, oh no, there's a square here, is equal to 16y. Now, we know that y is not negative. We already established that. That means whatever is here is not negative, because this is not negative. I can ignore this side and make a claim, and we can say that x squared minus y squared minus 1 must be greater than or equal to 0, because y is a positive integer. And with this, we can write this as difference of 2 squares. which is going to be x squared minus y squared minus 1 times x squared minus y squared plus 1 is greater than or equal to 0. Ta-ta-da-da-da. Now, it's not really safe for you to solve greater than inequality. It is better if you solve it when it's less than, because then you don't have to worry about what to do with the solutions. So what I'm going to do is I'm going to try to change this to a less than by multiplying both sides by -1. But if I multiply both sides by -1, this is going to stay as 0, but one of these will change signs. Let me change the sign of this one. Okay? Yeah. Or this one. It doesn't matter. Let me change the sign of this one. So if I multiply this by -1, multiply this by -1, I'm going to end up with, all the signs will switch here. It's going to become 1 plus y squared minus x squared times, this is going to stay the same, x squared minus y squared plus 1 is now less than or equal to 0. And now we can solve this inequality and say that 1 plus y squared minus x squared is less than or equal to 0, or you have x squared minus y squared plus 1 is less than or equal to 0. So from here, if you move this x squared here, you're going to get 1 plus y squared is less than or equal to x squared, or x squared is less than or equal to y squared minus 1. So at this point, what I want to do is recreate the original problem, which is x squared minus y squared, because I see it here in simpler forms, and see what's going to happen here. If I move this y squared over, it's going to become x squared minus y squared is greater than or equal to 1. Okay? This is a major discovery. Now, it was while I was thinking about this, okay, that I figured out that if the difference of two squares is greater than or equal to 1, and the two numbers that you squared are integers, then the absolute value, these two numbers, the difference between them has to be at least 1. Again, unless x is equal to y, the difference between any two integers is 1. So we can use that tool here, that the absolute value of x, because we're not sure whether x is positive or negative, but we are sure that y is positive, so I don't need to write anything here. You have to see this, because this was what I did not see. And as soon as I saw this, the problem was solved. Okay, so as you can see, the absolute value of x minus y is greater than or equal to 1, which means that the absolute value of x is greater than or equal to y plus 1. Or the alternative here is the same thing. See, here, if I say that x squared minus y squared is less than or equal to minus 1, it means that the difference between these two numbers is also less than or equal to minus 1. So this is going to be the absolute value of x minus y is less than or equal to minus 1. This is the biggest key. This was what kept me waiting. This was what kept me waiting, because this is true. If this is true, this also is true if this is true. And from here, see what I'm going to do. Because remember, I'm trying to generate this guy here. So what I'm going to do here is say, hey, absolute value of x is greater than or equal to, if I move the y here, it becomes y plus 1. And on this side, I'm going to have absolute value of x is less than or equal to, move this y minus 1. Now, if I want to get rid of the absolute value signs, I just need to square both sides. If I square both sides, see what I'm going to have? I'm going to get x squared is greater than or equal to, see, since everything is cool, right? Okay, is greater than or equal to, this is y squared plus 2y plus 1. Or here, what I'm going to have is x squared is less than or equal to y squared minus 2y plus 1. But I need x squared minus y squared. Remember, that's where I'm going. I'm trying to track back, and I want to get just y. I don't need y squared because I can solve it. What I want to do is restrict y as much as possible because I know that y is greater than or equal to 0, so y is always on this side. But I need to know where y is supposed to stop so that I can pick a number of options. Okay, so here I have x squared minus y squared is greater than or equal to 2y plus 1. Or I have x squared minus y squared is less than or equal to 1 minus 2y. Or let me write it as negative 2y. Let's write 1 minus 2y. 1 minus 2y. Okay? No, I don't need parentheses for that. Okay, so what does this do for me? If I square both sides to generate the original one, what I'm going to have is x squared minus y squared squared is greater than or equal to, if I square this, I'm going to have 2y plus 1 squared. Or if I square this, oh, this is less than. I don't want it to be less than. I want it to be greater than. So what I'm going to do is, because I want the two to be the same, to change the sign to greater than, what do? I multiply both sides by minus 1. So that means this equation is going to switch and become y squared minus x squared, and this becomes 2y minus 1. I'm going to change it. I changed it. Now this no longer looks like this, but as soon as I square it, it doesn't matter where they are. If I square this, I can rewrite it as x squared minus y squared squared. You see? Once you square a number, the minus sign doesn't matter, and this becomes 2y minus 1 squared. So now I have got restrictions. From this, I can clearly say that 2y plus 1 squared is less than or equal to this x squared minus y squared squared. Or I can choose this one and say that 2y minus 1 squared is less than or equal to x squared minus y squared squared. Beautiful. Now, which of these am I supposed to choose? And this was where I got insufficient funds in my account, because I picked this one because this is dominant over this. 2y minus 1 is closer here, so this leaves out many options. So this is actually the better option, but the first time I did it, I picked this one. I got some answers, but they were not all the answers because this was what had all of the answers. Okay, now I've learned my lesson now. When you're restricting, you want to take the biggest restriction and then you want to see all the options that you have in the middle. So right now, I know that 2y minus 1 squared, so this is the option I'm going to pick. Okay, you can pick this, you'll get answers, but not all of the answers. This one is wider. This is a wider gap than this one. Okay, now, because this is smaller than this, because of the minus 1, you dropped 2 integers. This gives you 2 less integers as options. This one you got 2 more, so that's why I'm going to take this one. Now, this is less than or equal to this, but remember the problem told us that this expression is equal to this. So I have an equation to solve, which is going to give me all my solutions. It doesn't matter what you're thinking. So look at that. So here we have 2y minus 1 squared is less than or equal to this, but this is going to be replaced by this. So we have 2y minus 1 squared is less than or equal. No, it's not. It's less than or equal to 1 plus 16y. That's it. You solve this equation, you get a range of values. Those are all the possible values of y. We go plug them in. We already got some, right? We already got 0. Oh, we only got 0 for y. Let's see what we get here. So if we square this, we're going to get 4y squared minus 4y plus 1 is less than or equal to 1 plus 16y. This equation becomes 4y squared. There's 1 here, there's 1 here, so we can't cancel each other out. If you bring this 16 here, you're going to get minus 20y is less than or equal to 0. If this is factored, you're going to end, if you divide everything by 4, we end up with y times y minus 5 is less than or equal to 0. So remember how we do inequalities? Y equals 0 or y equals 5, so it means that 0 is less than or equal to y, and y is less than or equal to 5. So this is the range of solution for y. If you use this, it's going to restrict you to 3. The number you're going to be getting here is 3, and you won't get a chance to try 4 or try 5, and you might leave out some possible integers. That's why this was the better option. Now at this point, we already know 0 is a solution. Let's try 1. So y can be 1 or 2 or 3 or 4 or 5. Okay, let's go. If y is 1, it means that, where is it? This is going to be 17. There is no perfect square that is 17. So we cannot take 1. That's how I just made up my mind. No, y is not 1. So we're going to go try 2. If y is 2, that's 32. There is no perfect square that is 33 because this has to be a perfect square. So it's not an option. Let's try 3. 16 times 3 is 48. 48 plus 1 is 49. Ta-da-da! So it means y equals 3 is a good option. And if it's a good option, then it means we can figure out what this is. If we say this is 49, so I'm just going to do it mentally and write the rest of the solutions. So plug in 0, 1, 2, 3, 4, 5, and get. So these are the solutions we're going to get. Already we got minus 1, 0, and 1, 0. Okay? Let's do that. Y is going to be 3. We're going to get 2 answers because it's a square. So we're going to get 49 here. So it means this number here is 7. This number is 7. So it means that this is 9 because it's 3 squared. So x squared minus 3 squared is 7. It means x squared is 16, which means that x squared, x has to be plus or minus 4. Remember, x doesn't have to be positive, plus or minus 4. So that's 16. We got that to be plus or minus 4, minus 4, and plus 4. Okay. And the next set of answers, if there exists any, we didn't try 4. Let's try 4. 16 times 4 is 64. 64 plus 1 is 65. It's not a perfect square, so you skip 4. Let's go to 5. Hope we can skip it. 16 times 5 is 80. 80 plus 1, is 81. It's a perfect square. So y equals 5 is a solution. So we got 5, and we got 5 here too. Let's go see what the values are. So since this is 81, a perfect square, then it means that this must be a number which when squared is going to give us 81. So the number here has to be 9 or minus 9. Okay, whatever is inside this. Now, because this is 25, if I add 9 to 25, I am going to get 34. But 34 is not a perfect square, so no. So this has to be minus 9. So what I have is minus 9 plus 25 is going to give me 16. So here x is 4. So this has to be minus 4 and plus 4. And because of this restriction, I don't need to think about any number beyond 5 because of what we've done. And this is the biggest restriction. And these are the solutions. This was actually, I spent quite a while trying to figure this out. And I am 87.9% positive that this is the set of solutions. I think I should graph it actually and see how many times they intersect. It's just hard. Never stop learning. Those who stop learning, stop living. Bye-bye.